Or do you think
the community is for laptop doesn't work with so everybody asks if you have any other laptops.
we can try, but all the laptops we use are
다 똑같은 거 쓴다고.
그러세요?
and we were using a similar laptop yesterday.
그리고 어제 비슷한 거 썼다고.
근데 비슷하게 하기에는 잠깐만 제 걸로 한번 해보고.
We'll try with his laptop.
Okay.
And see if that works. Okay. It does have.
Power line.
USB. I guess this one doesn't have HDMI. Oh, I thought it did. No, that's my other one. I'm sorry. We're trying to find the magnetic combination here to get the projector working. While we're waiting, Gene has volunteered to take notes. Can somebody volunteer to be a Jabber scribe? Anybody willing to Jabber scribe for us here? Please? So one more time, if you're here for trans, that starts at 11 o'clock. This is a double, 2 short sessions and 1 long one. We're trying to get the AV to work. I need the Jabber scribe. If anybody's in the Jabber room, if they'd be willing to. That's on the other. Yeah. Surprised this didn't show up yesterday. While we're working this, the slides are posted. So if you can copy them down to your computer until we get this going, we can do it without projecting. Hopefully this will. Yes, I posted them this morning. Are they not showing up? I posted them this morning. So this is modern. again, if you're here for turn, that starts at 11 o'clock. So next thing would be imagine note well. I think we've all seen note well enough times that we probably don't need to have it shown anyways, but note well, the note well. The agenda, we have 3 topics. One is advancing the problem statement document, and then Chris and John will both present the drafts that they've submitted prior to the meeting. Agenda bashing, if there's anything else people would like to talk about, please say so. So on the problem statement draft, we went through working group last call and got 0 comments. And I think as has happened with some other working groups, the STIR has kind of taken all the oxygen out of the room for related topics or other topics. Oh, they're leaving. Okay, so I need to do my shadow puppets here. Anyway, in order to advance the draft, we need a little more review and comment on it. Not a lot, I don't think, but if we could get a couple of volunteers to take a look at the draft and post comments on the list, that would be very helpful. The framework document, yes. Okay. Thanks, Adam. Anybody else be willing to? Henning? Great, thanks. I think that should be sufficient, right? Yeah, okay. Anybody else that wants to, please do. I mean, the more the merrier, but we just need to make sure that we show enough interest and then enough indication that the draft has been looked at to move it forward. Okay, and so, again, sorry for the difficulties here. So next will be Chris. I guess if you can bring your, I can set my laptop up here for you to see if you don't have it.
So it appears that plugging directly in the middle of the room, you can't get a signal there. So if you want to drag something up there and project in the middle of the floor, it might be a good
Well, I can try to plug mine in if you want to. It's just the.
Mary also is on.
Oh, they are. We assume they're coming back and they left their laptop in there.
You found mine. Okay.
You might be able to grab and share it.
Did I read this to you or did you? Was I gone? I need more information. Okay. Well, thank you.
I'm not plugging it in.
Okay.
Okay. Thanks.
I thought it out.
So we can plug it in.
Yeah. There's no one who's filed yet. Yeah, right. But he's like,
So I'll get started, right?
Yeah, go ahead.
Okay. So I submitted a document. There we go. Identity registry. This was basically a brain dump on something we've been working on internally, and very compatible with the concepts of modern as well as some of the stuff in Terry. I think the goal here is to maybe talk through and see where the commonalities are. But I'll go ahead and talk through the slides, talk through the document first, and John can present, and maybe we can discuss afterwards. So it's got a couple new things that maybe aren't part of the current Terry stuff. It also has, we actually have an implementation that we've used with the drip stuff. So it's sort of nice from that perspective as well. And I'll try to talk about those, how those things sort of hook in, although drip is sort of generic, so it's not an explicit thing. So one thing we do is explicitly associate services. And the other probably really big thing is having a model where you can have multiple public identity associations and a routing identifier that's sort of explicitly a related but separate thing. And I'll talk through that a little more. Next page. So the actors in this model, and I have the diagram on the next page, but the main actors in this relational model, and that's how I sort of modeled it in the document, is the provider, the one that actually provides the service and manages customers and manages the network, probably. The user subscriber, so the person that actually, the actual human being that is subscribing to some service from the provider. The service identity, that's the identity of the service that the subscriber is actually subscribing to. And it's important to note here, a provider could offer multiple services that a user can subscribe to, or the same public identity could be associated to multiple services across multiple providers. So just flexible from that point of view. The public identity is generally something that you can prove an identity of. So telephone number, obviously being one that we're interested here, but that doesn't mean it couldn't be extended to other forms of identities like email addresses and things like that. And then routing identity would be some probably URI type of thing that I'll talk a little more about how we have been using it. But it, in the basic case, it would just be like the SIP URI. But the intent here is that it's sort of globally routable identity.
Did you want to take questions at the end or now?
I can take the questions.
Just I wanted to make sure I understood what you meant by service identity. Can you give an example what that would be?
So I have an example where it might be VoIP as a service, but you could think of it as maybe an application. So
so this is not describing a user describing a broader service itself. Like it would be everybody who subscribes to a messaging service, for example, would have message in their
exactly. Yep.
Okay.
Yep. Well,
John Peterson, but you also mean like, Facebook's messenger service, right? When you say it's globally unique, that's, I think, the interesting question about it is this,
it's
SNS
unique
service
to
or
the
is like
provider. Yeah, actually, that's a good point. Yeah. So it can be unique in the scope of the provider. It could also be globally unique. So like VoIP probably would be one that you'd want to be globally unique because you have multiple providers, but it could also be unique within a provider. And we use sort of a qualified domain convention, at least that we've implemented. So it would be like voip.comcast.com or something like that.
So this would be primarily, if you're talking about this later, just tell me.
Okay. Yeah.
But the idea, when I can see people have talked about the ability for many years about having essentially separate providers for different generic services. Mm-hmm. So I could have an SMS provider, for example, and a voice provider, mm-hmm. to take a very realistic example.
Yeah.
And in this case, I would have two records, one which said SMS, we have one that says voice. Mm-hmm. I don't really care who provides voice except for a routing identifier, but I do care if I want to route it to that. That actually turns out to be a real near-term problem to the extent that you followed it for real-time text. Because there will likely be a combination of over-the-top applications that provide real-time text and a classical IMS, whatever type of legacy voice type of model, and I need to route separately. They're going to be in different providers, probably, maybe a white label provider on the RTT side,
Right.
and classical provider on the other. So that's why it makes a big difference whether this says, well, unless there's a hierarchy implied, so that if I don't care that it's voice Comcast, all I need to know is voice and I'm good. Is that what you're saying?
Yeah, so maybe to step back a little bit, the intent is that I know that I want to contact Henning at 215-555-1212, and I want to contact you for real-time text, for example. So I look in the registry, I do a query for the service of RTT for the public ID of 215-555-1212, and I get a globally unique routing ID that goes to the provider.
Okay, that's exactly what I was hoping for. Thank you.
Yep.
And to be clear, I think that is totally in keeping with what's in the model framework and basically what's in Terry, right? I mean, there's a subject to these things. There's an attribute you can use to specify void, things like that. And so, yeah.
Yep. Okay, next page. So this is just the diagram that's in the document, and I use sort of a relational model here. So actors and verbs to describe how they're related and used with each other. So hopefully that sort of just explained what we just talked about, unless there's any other questions. Yeah, right. Pictures are good. I guess I could try to incorporate arrows in the text thing, but we'll see. Yeah, no problem. Okay, so this is sort of a general description of some of the API functions that I think we've talked about. It also came a little bit from some of the stuff we tried to talk about before STIR sort of took over in the NNI working group. But so, basic requirements for telephone numbers and identity can be extended to identities. So the ability to have unique identifiers where there's a single owner, enforcing that, and having a pool that can be queried for available things. And that's probably more relevant to telephone numbers. And then the ability to support block levels and perhaps wildcards on other types of identities. The ability to update, transfer, and port identities. So update providers, update, transfer them. And then signing transactions, which I think John has in his document as well. And then the distributed registry thing. Yeah, so just to talk about the distributed registry a little bit, I actually in the diagram have one thing I noted as private, the user subscriber. So obviously details of the user subscriber should stay private to the provider. But we would expose some of the RESTful interfaces that we develop here to the distributed registry in order to do gets and puts against when updates are made and, get pushed over the distributed channels. And that's sort of essentially, we would map those into the specific implementation of the registry hooked into DRIP in the case of DRIP. Okay, messaging and control flows. So here we go. As I explained to you, Henning, the most queries would always be in the context of public identity in the service. So that's sort of the unique pair that would identify which routing ID would be used to route. And we just talked about global uniqueness as well. So, the allocation must be unique. We need to make sure that there isn't any race conditions in terms of allocating numbers. So the idea that if you did a get to check if something's available and then you try to do a put, we should make sure there's no race conditions for somebody else getting in between. And that's sort of covered in the draft, but it's good to note in this as well. So next slide is an example. The telephone number would be the public ID in this case. Service ID could be VoIP, as I described before, and RTT and other things, and whether they're globally unique from a federated point of view, or if the provider just wants to provide a unique service, that's possible as well too, although less important for the distributed case. The suggestion here would that the routing ID would, this is sort of another important concept that at least how we have implemented it, that in the case of the SIP URI, the domain actually represents both the provider and the service. So I think I mentioned before, like voip.example.com would be the domain because it's the service ID, and then the domain that represents the provider, and then the identity is put before the @ sign. And then sort of the timestamp, signature, and the pointer to the public key, which I think aligns with what John has in his document.
Yeah, John Peterson again. I think it is definitely aligned. One of the things that I'm really interested in about this, I guess, and we can get into this a bit when we talk about how this aligns with the Terry data model, the degree to which you think the routing ID should encode in the domain what the service is. In the sense of, this is kind of a question we came up a lot in the early architecture of enum, like is SIP a service? And if so, what service does SIP provide, right? SIP provides this rendezvous function that allows endpoints to explain their capabilities and to kind of negotiate what communication protocols they have in common. And this question of kind of what goes into the routing infrastructure, right, that lets you discover the SIP endpoint you want to reach versus what then should the two endpoints negotiate among themselves is a really interesting architectural division. I definitely agree we need something like what you have here for a service ID that lets you say the routing ID I'm looking for is the one for VoIP. And what that means is that the thing that's returned should work for that at least. But would it be like a problem if it also worked for video? I guess is my question, right? I mean, do you want it to be,
No, and I think that is part of the definition of what that service ID represents, right? But for me, it's also like, if something routes into my network, if it's VoIP, I might want to send it here. If it's RTT, I might want to send it there, so there's a whole bunch of other things, and it's globally unique as well. So I think there's a couple things there. But the idea would be, even though it's using SIP as a signaling protocol, which is sort of generic, you're qualifying what that identity is intended to represent in terms of the service that's being offered within your SIP infrastructure.
I mean, I guess, the substance of my comment is really that probably as we look at aligning this model with what we're doing at Terry, I would probably argue that there will be other ways, like in the records and things that Terry reflects, to show what the routing use is of these things. Encoding them in the domain that way is a very specific, kind of implementation-specific way to address this.
I'm open to other ways. That's how
that's
happens to be how we did it, but certainly we're welcome for feedback.
I hope that this is a place where we're open to some flexibility. I think there might be advantages to having separate ways to signal that, both in this routing layer and then down at the SIP layer.
Hi, Dave Crocker. Similar or related question. This appears to be, by virtue of having the routing ID, somewhere in the realm of source routing, rather than the model which moves the routing to the real-time query at execution time, so that you take the target that you want, you use that to find some real-time information rather than embedding it into the request. Any thoughts about why you're taking the embedded approach? If I'm understanding correctly, which
well, let me make
is always
sure I'm following what you're saying.
So I always use email references, so that's what I'll do.
Sure.
Once upon a time, you actually could embed a source route into an address. There would be the place you want to go to, but you'd say,
Right.
go get there via this and this and this.
Yeah.
And that was in what the author would specify.
Yep.
And you might guess that wouldn't scale real well. You'd be right.
Right.
And so the current model is I say where I want to go,
Yep.
and the underlying infrastructure does a bunch of queries and
Yes, yes,
redirects and
right,
all sorts
right,
of
right.
silliness. MX is the obvious reference.
Mhm.
And this appears to be more like source routing, if I'm understanding the role
Well,
of the
so I
routing
think
ID.
it could be flexible, but the intent is to make it more straightforward, I guess.
The difference, this is Henning speaking, the difference to email was that it was generally speaking one service, maybe with flavors to it as to its capabilities.
Yeah.
And here you have a problem that you have a single identifier, the phone number in this case,
Mhm.
and multiple services that are operated by differently administratively distinct bodies.
Yes.
And there could be overlap in the sense that you could have a service that offers messaging and voice and video, and you could have a service that only offers messaging, for example, to take a very
Yep.
plausible example.
Right.
And messaging could be both proprietary or IETF standardized or something like that.
Mhm.
So you do clearly have a possibility. You could do late binding in the sense you just have a bunch of identifiers and see whether, if you speak with protocol, whether it supports any of the things that you care about.
Yeah.
And then you just have to try until you find something.
Mhm.
Or you can essentially do a hint as to what services you might even want to look at
Right.
in that, because they generally don't change all that much
Yep.
over time. As long as both models are supported, I don't think of it as source routing as such, as in more as a service selection.
Mhm.
Namely, what kind of services do I, very high level services, obviously
Right.
we're not talking in that. The problem will be, and I don't know how you envision handling that, for services, for routing IDs that handle multiple services in combination, let's say voice and video, just to
Right.
take an example, if they're separable, would there be two entries, or would there be a multi-valued service ID, as in there would be enumeration of this thing can do voice, video, text, say
Yep.
to take a classical version? That changes how you do lookups, it changes the relational structure of your database. It changes my ability to, for example, ask for a service that supports all three at the same time, which might
Yeah.
be something I care about. All of that.
I think all of that is intended because one of the things that is an interesting use case is sort of what carriers are supporting today in terms of I have my legacy SIP, I have VoLTE, I have RCS, and I might want them to enter the network at the same place, but then I might have other logic internally, routing logic that might push them to the RCS specific services or other things. So we could either do that explicitly in the registry or implicitly and then have internal routing logic that could, so I think it'd be good to support both models, and then the carrier or provider can decide how they want to treat those identities. Because yeah, we have a use case as well where we have sort of a, we offer messaging and voice and other things, and we sort of have an umbrella service that we use as an identifier, and do that and then split off depending on the application. But I could see it both ways, actually.
Dave Crocker again, just for completeness, something that I'm pretty sure everybody in the room already knows, but Henning's point about multiple service is what prompted going from MX to create the SRV record so that you could underneath register for different services.
Yep.
Yeah. Also, just in terms of Terry alignment, sorry, John Peterson. One interesting thing about the Terry model is we do have, in fact, explicit source routing in it, in the sense of, there's a concept of the source of a query, and there can also be the concept of a route source. For this query, tell me what the route should be if this is the source of the traffic, in other words, or the anticipated source of the traffic.
Yeah.
And that is a property, I think, that turns to be very meaningful for exactly those kinds of service provider cases you're describing, or inside of a single network.
Mhm.
And there will be, if your route source is inside it, then it's you need to exit through particular gateways or whatever for particular services, which would be very different if you were just out on the public internet, say.
Yep.
So that is something I think that definitely needs to be a part of the model of this.
I guess next page. And then just wrapping up here with some more details I included in case we need a discussion, but I think we've covered a lot of it. So just in terms of the API specific stuff that we need, this is intended to provide guidance. I do have some API references documented. I didn't have a chance to put them in, but I figured we should talk about it before we start defining interfaces. So basically, the idea of update entries, porting numbers, the gets inputs that are put and posts that are associated with that, and then on the next page, removal, deallocation. If it's telephone numbers, the ability to put that telephone back into the pool of available telephone numbers, those concepts. So that's the overview. Okay.
Okay, John?
John Peterson. This is really great for a number of reasons. This is kind of what we've needed in Modern for some time. We've been having a relatively abstract discussion about kind of what we think the principles would be that we would need to, let's say, address the enum-like problem in a more web-like, I guess, way. To try to figure out a rich query semantics that'll let you express interesting questions about numbering resources, that will let you create records related to numbering resources. They'll let you have these records exist in a clear kind of SCRUD ecosystem. We can create them, we can update them, we can delete them, and so on. And I think this, you can go to the next slide, I'm sure. This has been a perennial difficulty for us as we've looked to extend enum, or even to try to figure out kind of provisioning systems that would work for enum in the past, because we never really looked at it from that perspective of the record being something that would kind of atomically move through that life cycle. And the problem is, of course, you can't really define much about that information model, and Terry is in fact an information model, without having some really concrete examples that you want to work with of what the data elements would be that you're going to put into it. Like, we can define in the abstract what it would look like, but this, Chris's presentation there is a great example of the kind of thing the Terry model should be able to do. If we look at Terry and say, actually, we can't figure out how to map the kinds of things Chris is talking about to Terry, then obviously we did a terrible job designing it. Because this should be a layout. This should be very straightforward, at least for us to figure out how to slot it in and how to extend it to accommodate that. So let me talk a bit just about Terry before I get into the new document and into alignment with Chris's stuff. We have a draft. It's called Draft Peterson Modern Terry. This is for telephone-related information. That's what Terry is short for. We now have a 02 of this. Again, still an individual submission. We've been having difficulty, as Steve intimated earlier, getting enough eyeballs on the framework. Terry is, in fact, an instantiation of that framework pretty directly. So I think when we feel we've got that a bit more solid, we can talk about whether or not Terry should be something that we'd adopt. Really, I only made a couple more tweaks to it, though, honestly. I mean, again, I think based on some of the things in Chris's draft, I can see ways I might extend it, maybe even change some of the fundamental elements I imagine are associated with records based on the way Chris is looking at it. There are a couple ideas I'm going to talk about that I think probably should be promoted into that. But I think kind of the next step, and this is what we want to talk through today, is what we think it would look like to take Chris's model and to build a Terry binding that is based on that exact kind of registry model. Since it's just an abstract model, I also have noticed, I think it's kind of hard for us to talk about this in too much of the abstract. So I wanted to at least show a data format that we could mint these records into. Really, we've just been talking about the information model at a very high level. These are the fields we imagine would be in it. So I put out a little bit of a straw man draft. Next slide. That will show, I guess I talked about the draw my model on the next slide, but that is trying to put Terry into JSON in a pretty casual way, I'd say at this point, because I think we do want to know that we've got the right data elements, again, given something like Chris's registry example. Yeah, next slide. So what we really want to be able to do with these JSON elements that I'm going to be talking about today is to fulfill what we call the Terry operations. And this speaks very much to the API calls that Chris was just referring to with his gets and puts and deletes and so on. We want to really have three things you could do with Terry. You want to be able to acquire numbers. This is both the searching capability you're referring to. How do I interrogate number inventory and then get a single number or a block of numbers out of that inventory and have that be assigned to me now, at least whatever that attestation of assignment means in the Terry context. There's a management operation that both enables you to provision initial information against those records when they've been acquired in that fashion. We'll also let you modify them, port them. Things like that would all fall under that management operation. And then finally, the retrieval operation. And retrieval is where we started. Retrieval is the enum, basically, problem of, okay, we know that there are records out there for this, given who I am, given the situation of the network resources associated with it. How do I get that information? Who do I ask? And what does the query need to look like? And again, the core conceit is that we've looked at these kind of in isolation, when we've gone through these efforts like Spearmint or like Drinks, enum, we've looked at parts of these. And the conceit here is that obviously these protocols are all accessing and mutating a related set of information, some kind of an atomic record. And so Terry's ambition is to provide a common information model for that record itself, and then for these operations that operate on the records. Next slide. So it looks like this. This should look at least somewhat similar to Chris's picture, though a bit different. The service provider in this kind of model, really the communication service provider could fulfill any one of the main roles that we see in this. Obviously, the intermediaries that client requests are going through is someplace the service provider is likely to be. That big thing labeled service is another candidate for it. Even the authorities on the side. So if AT&T owns a numbering resource and they want to be able to provision records associated with it into one of these databases, they could also be a service provider. So these are logical roles that are played by participants in the ecosystem. And we imagine, we kind of base this on a DNS-like model where there are registries and registrars and registrants and so on. So given that there's a separation that is at least logical in the architecture, though we imagine that for the IPNNI sorts of cases, those functions would largely be completely composed. For the more distributed registry case, though, that would actually be very different. The distributed registry case would look much more like where the authorities that provision Terry records, and these Terry records are then available to be queried by people, could be the service providers themselves. They would just be authorities where these records, the service is a distributed thing that kind of lives out in the cloud or in the DHT. And so that would not be the service provider probably for a DRIP-like case, or at least it would be at a layer of indirection from the service provider. Unless Chris would like to correct me in my characterization of DRIP.
No, I want to understand what you said, the difference between distributed and non-distributed.
So you can imagine a case where you, as Comcast, obviously you have customers, you're both the authority and the service people query for those customers. Yeah. Then I can imagine a case where instead we move out the intelligence that people query into like a DHT set. And in this case, you would remain the authority as a participant in it. In other words, you'd be creating the records.
You mean internal versus external view, or sorry?
Well, so I mean in this instance that the place that you query to learn these records from the retrieval operation in a distributed registry would no longer necessarily be like your service, right? Comcast service. And it would live out in this cloud. As a consequence, although you're the authority for it, logically you generate the records, you sign them, and they go out into this drip cloud. Right. You aren't the service anymore that literally gets queried in the sense of service in Terry, right?
Okay.
That's all I mean.
Federated service versus an individual service.
Or even more radically distributed than federated, right? Yeah. I mean, again, if you can kind of take all of these DHT-based approaches, their logical extreme, imagine a registry that's very decoupled, right, from the operation of any individual service provider.
Right.
Do other people get this, or other people uncomfortable shaking their heads? I don't know.
Alyssa Cooper. Would then the acquisition flow also go through this federated distributed service? And how does that relate to the authority's authority over acquiring.
Sure. So, I mean, I think DRIP is based on the notion, again, I hesitate to characterize your own proposal too much in front of you, but yes, there would be some number ranges that would effectively be seeded to this distributed system. And if you're a participant in the system, you can then use the acquisition interface to seize free numbering resources. When you delete, you can also release them to this, right? And what really the acquisition process always gives you in Terry is authority, right? It makes you into the person who then can provision the records and say, okay, for this service, these are the service fields that I want to associate with that in the record.
So is there not a model where that would look beneficial for retrieval, but not for acquisition? Like, do those things, they have to be coupled?
Oh, sure.
Or?
No, I totally agree there is.
Okay,
I'm just speaking
okay.
again to this very specific, at least as I understand it, proposal for DRIP, which I think is based on this notion that you want a free, in fact, I think that's the central conceit, that you want even the acquisition dimension of it to be distributed in that way. It's totally possible to do the retrieval in that very distributed way and have the acquisition actually be very centralized.
Okay, thanks.
Henning, I think it might be helpful to distinguish two kinds of distribution. Namely, one is what you might find is just a physical distribution, more like if you want to use blockchain as an example, where the idea is, generally speaking, or DHT, as you mentioned, where this amorphous cloud of possibly independently resourced entities, but the ideal is that collectively or individually, they all provide the same information. They're not, except in some mechanical way, like for DHT, the identifiers are just split for mechanical reason, like in the DHT, with identifier ranges, but there's no particularly administrative coherence to that. It's not like one server holds AT&T's records, the other one holds whatever, the Canadian records or something, the country. And then you have a separate model, which is what I think of more as a federated model, which is indeed there is an administrative division between logical entities, which themselves can be distributed. I mean, that's certainly doesn't have to be a single logical SQL server, and where I actually can just go logically, like I can do to DHT, where I can go to any node and say, give me that mapping, and it will do its thing by just DHT mechanics. Here I would have to say, oh, this is a Canadian phone number, so I need to go to the Canadian server based on some other lookup or based on the identifier prefix, in this case, area codeless country code, and do that. So I think it's helpful to distinguish those two models simply because they have different implications in terms of the mechanics of looking up things. In one case, the underlying system does that all for you. There's blockchains and DHTs and what have you do that, or the kind of models that we implemented in one of the early prototypes, which all does that, by plain replication in that case. And the second point that I think has come up indirectly in both presentations is that I believe it would be extremely helpful to think early on as to who can associate data with a record other than the original provision. So, and this is like, say I have a Comcast voice service, but as a subscriber, I want to attach, say, a certificate, a Better Business Bureau certificate to it. Comcast isn't involved with that at all, but somebody is. Or in video relay service, to take a very concrete example, we have this problem that we need to run a two-layer database, essentially, because we have a service provider that provides telecommunication services, and we have a relay provider that provides relay services in that. So it's this two-level database, which works, but it's more complex probably overall than it needs to be. It makes porting harder, all of these type of things. And so if one could associate different identifiers with that may be opaque to the entity, but somebody can actually essentially have parts of a database record that I can add to as a subscriber, for example, that allows me to add information to that is completely irrelevant. The service provider doesn't care. I think that would make
Sure.
adding functionality to databases much simpler than it is today, because today even adding a single field is literally a federal procurement action and
Heard that,
a
actually.
Nancy
Yeah.
3-year process. And I mean, it makes adding features to numbers, the hurdle is extremely high, which means most of it gets kludged or never get done.
Yeah. So just because, so Terry does have the concept that there can be multiple authorities to the same number. And a lot of this stuff actually falls out from that. In other words, when you're doing a retrieval operation, the nature of your query will perhaps limit the number of records that you'll get back. But there could be subscribers who provision records against a number. There could be service providers who do it. There could be all, and necessarily they all have different signatures. Like there's different scopes of authority. So I mean, Terry is built on that very pluralistic concept. I think that there's going to be anybody who has some authority over a number, and we can talk about how we think that's defined, but can provision these records. And really it's up to the retrieving entity whether they trust the credentials that were used to attest them. And if they do, then they use the records. And if not, they don't. And I think that gives everything you just wanted from that.
Yeah, I was just going to, because Chris went, I was just going to make the point of DRIP, and I think distributed systems in general, the idea is that you want both as a consumer of data coming from other folks and the initiator of information going into the system, you want a complete view of the system. So like, even if, so let's take the example, if you do have a Canadian registry and a US registry, I probably want read access on the Canadian registry. That can exist separately, but I still want an up-to-date copy because I want to route my telephone calls to the right place as soon as, Shaw implements, takes hold of a number and allocates it to a customer. So I think the idea of replication and distribution is sort of a necessary condition, at least in the ecosystem where you're both reading and writing and managing data.
But I think it also, again, that this lets us treat the service as something that could be run by Comcast, could be run by, you don't know, you could find these records like in a bus station, right, and copy them into your computer and still trust them, again, provided you trust the authority that generated them, you have the cryptographic assurance of them. And that lets this apply equally well to a very distributed model like that, as to one where it's really the service provider you go to, where I know I need to go to AT&T and ask for this. So Terry is designed to work at either of those extremes. That's one of the constraints of the model. Next up. Basically all these operations break down to a variety of requests and responses. And these are what my little toy draft trying to show what requests and responses might look like for some of these operations is intended to make a bit more substantial. And this is where we can begin to see the questions of what the alignment is between this work and Chris's work. Like, for example, as we talk about a request, all requests have a source. All requests come from someone. There's some administrative identity of I'm the originator of the query. And that may determine where the query lands in some cases. That may determine whether or not the query is authorized in some cases. That has a subject. There's some specific resource you're asking about. I think this probably fits in with a public ID that you're describing for the most part, Chris. Attributes that are associated with the Terry request can include things like a service discriminator. VoIP is given as an example of an attribute in the Terry drafts today. And this will ultimately yield a response. Response will have a response code. And this could just be things like success if you're provisioning a record, or failure if you're provisioning a record. It could be failure if you're asking for records associated with a resource that doesn't have anything associated with it. The subject has not yet been allocated, say. Or responses can contain records. In some cases, provisioning requests can contain records. So really, again, the record is the fundamental building block of this. Records can cover ranges of TNs. They can cover identifiers other than TNs. Records are very kind of broad in the Terry ecosystem. Stop. So yeah, I mean, this is where we can kind of look at what the elements were that you were identifying and say, okay, are we roughly in the right, at least ballpark for this? In the subject of this that you see, and again, this is a very rough sketch that I'm trying to use to just make this a bit more concrete than the just endless lists of attributes, which are what is in the draft today. In the subject field, you can see a service discriminator. That's the T that you see for TN right before the telephone number. The attribute here indicates you're looking for a specific service. That service is SMS. So this is a discriminated request for SMS associated with that telephone number. And it does have this request source in it. In this instance, it just gives you a logical identity of who the request is coming from. Obviously, doing some kind of cryptographic thing for that could make sense in some contexts. In other contexts, it'll be clear if you're using actually REST to do something like this. Obviously, there are HTTP level mechanisms we could rely on to authenticate the source of the query. And similarly, probably we would be encoding in the URL itself a lot of the subject information. That would just be mirrored in a RESTful API between what you see in subject here and what would go into the URI itself. But I mean, overall, just looking at the kinds of things you're talking about, I mean, I think obviously we have a lot of overlap in terms of, what was already kind of in baseline Terry and what was in your model. Next slide. Yeah, we have some responses defined in Terry. I haven't really gone to the trouble of creating like response codes yet or anything like that. Obviously one would if we're bringing this forward, though again, those two would probably have some mapping to base HTTP codes for RESTful API for a lot of these cases. Here's an example of where the source of the request would not be authorized, and you'd get back a very simple record of this form. Next slide. Yeah, in terms of what goes into a record, this too is, I think this may be a place where architecturally, I'm maybe thinking a little bit differently than your model is. I think you're looking at the API, whereas I'm more focused on the notion that there's this object, right, that lives in these databases. And the purpose of the API is simply to operate on that record. Because I architecturally think of it that way, I'm most concerned about what goes into the record itself. And so a lot of the Terry discussion is about how you populate it and what kinds of things might be in it. But I think this is I think we've probably gone through most of this before. I think the entities as well in the modern framework line up pretty well with the entities that you're identifying in the registry identity model. But a concrete example might be helpful. Next slide. So here's me trying to give a success response to show what it might look like to have put in a query and actually getting a record in return from that. So as you see, all these records have like some kind of a UUID in them. They all have an authority in them, an X5U, just as unsurprisingly the registry identity was. We're both thinking that from STIR necessarily. A signature that accompanies that. And again, the combination of that authority, in some cases maybe the contact, and the signature lets you know who it is that you're trusting when you're trusting this record. And that is fundamental to the way we look at Terry. Again, you could find one of these on the floor at a bus station. It's fine, provided the signature checks out and you trust the trust anchor that is responsible for creating the record. In this instance, the payload here is just that service field that has a URI, and it's a SIP URI that you got from that. Obviously, there can be all kinds of attributes and discriminators that are associated with that service. There can be a menu of such services in any single record. And to your point, Henning, you could get a bunch of different ones like this. There could be one that was provisioned by a user that looks like this, and then a very different one that's provisioned by a service provider. And as the consumer of these records, depending on who you trust and why and what kinds of services you're trying to reach, you can exercise the services that are described in it as you see fit. And that's a basic idea, right, behind all this, and kind of a basic example of encoding. So I think the next slide is on, I think I already talked enough about this. Next slide. I already talked enough about this too. Keep going, keep going. We already went through what retrieval and these things are. This is what we actually need to talk about. This is the interesting bit. So I took a look at Chris's draft, and we had like at least a brief conversation about this. Again, I do think most of these concepts are directly comparable to things that we have in the Terry model today. One thing I saw actually in the registry identity draft that we don't do in the Terry model today, I was interested in, is having an allocation timestamp associated with the record that lets you know like when the record specifically was created. I think that is probably a really useful feature for this to have that I could see moving into the baseline of the Terry information model and into all the kind of instances like this that we would build on top of it. But in terms of the identities and things like that, again, we don't have like an exact mapping to what you call service routing and public identities, but I think we have a slightly different combination of things that end up making up much of the same semantics. Clearly, we treat service not in the this is Facebook's SMS necessarily sense of we're going to create a UUID or something for an individual provider's instance of a service. Though, of course, pointing to a URI that is a service URI is necessarily pointing to some service, right, that is provided by some service provider. And as a consequence, I mean, I think we kind of get that any way that we depict the services in a model like this. So the real question is to what degree the discriminators for the services, things like VoIP or SMS and so on, are sufficient for that, or whether you think that we want to have something more like a UUID to designate, well, this is Comcast's VoIP service. And architecturally, again, I think it's 6 of one, half dozen of the other, to be honest, because you do get that, ultimately that URI, it's going to tell you it's the URI to Comcast service. Unless you think there's some reason why the inspector of the record would trigger something that would be like some service logic based on the fact that it's Comcast's VoIP that would not be obvious from looking at the URI. So I want to tease out a bit what you think the requirement is behind this.
Well, partially it's just the pure routing itself. So you're talking about service incorporated into the routing ID, as I call
Why
it.
don't you flip back to the, actually, unfortunately, it's like back 15 to my example record. One more, this is good, yeah. Yeah, so I mean, example.com and the service element here is where Comcast's domain name would go, right? If this were Comcast's service. And so kind of the way that I thought about this, U is an indication of what goes into the service field as URI. And if you do reference it, you'll be contacting them for X, Y, or Z. There could be attributes then that are further associated with this. And I showed this in the query. They would say things like VoIP or SMS, right? So you could say this specific URI will have these attributes associated with it. But all you need to know to figure out that this is Comcast's VoIP service is to see that example.com there says Comcast.net, right? And that the attribute associated with it is VoIP. And so I guess what I'm asking is there's some further need to have a UUID for the service beyond just like VoIP?
No, you can use that directly. I don't think I was advocating for a UUID. Is that what
I thought it's a globally unique identifiers, right? Not necessarily UUIDs, but globally unique identifiers for the services. But you kind of said you wanted to have it both ways, where that could either be very generic, right?
No,
like
actually, we specifically use some textual.
Okay, just like
thing. Yeah, and we do that for a couple of reasons. One is from a routing point of view, it's more explicitly says where you want to go. We also use it from a logging point of view. So if you're doing things in one application versus another with the same identity, you can see that. One other concept I can bring up that we have, which is not necessarily related to that, but is something interesting I just remembered, is for our routing IDs, we actually use UUIDs as the user part. And that is to avoid any leaking of PPI data in any of our signaling or logging systems or other things. So that's a sort of another orthogonal concept to think about. I thought I'd just mention. But from the domain part of the routing ID, yeah, I mean, I think it's nice to have the explicit domain and service association there, just so you know exactly where it's going to. And so because ultimately, if I want to send a VoIP call to 215-555-1212, I need those two pieces of information to get the globally unique routing address or URI that I'm going to send it to, and why not include those explicitly in the URI that's used to actually route it. Yep.
No, that totally makes sense.
Yeah.
I mean, I guess maybe you could flip back to the Chris comparison slide. Thanks. I mean, I guess I'm confident from our initial look at this anyway that we could probably converge pretty quickly on what we think the necessary fields are to cover the identities in this, probably as well for kind of the provider subscriber distinction. Again, since Terry doesn't draw that distinction explicitly, it just says there's a contact, right? And like the contact for this record could be a service provider, it could be a user. The point being, it's ultimately the authority of the signer that determines whether or not you trust them. And so we look at that, I guess, at a higher level in the way that Terry is oriented. The allocation timestamp I definitely want. And from the operation perspective, again, the operations in Terry were designed to do all the sorts of things you do with telephone numbers. So unsurprisingly, things like porting and so on are entirely what it's all about.
Yeah, I guess I was just thinking back to the name. I mean, theoretically, it could be really anything, right? Like, as long as it's, there's a way to route it.
Yeah.
You know, it could be X, Y, Z. As long as this provider understands where it's going to, and
well, again, as long as the entity that it gets routed to.
but
right,
if you just
then,
use the domain, then that provides less indication. Or you could always incorporate it in the user part too. There's lots of, I think we're just talking convention here.
it's syntax, I think,
Yeah.
really. I mean,
Right.
we all agree on what the information is that needs to be conveyed. The question is just like, where do you stick it, right? Maybe you stick it into the domain name itself. It's like VoIP Comcast.net, or if there is, Comcast.net, and then there's an attribute field next to it that has like VoIP in it, right? So this is merely syntactic, right, convention. I mean, an interesting component of doing it the way that I'm describing is that you can have multiple attributes associated with it, say. So if you have this address supports VoIP and video and SMS, you could then have this URI with 3 attributes associated with it. Let's say the services I support are VoIP, video, and SMS. Whereas if you're encoding the domain name, and that's like voip.comcast.net, how do you want to do that? Do you want to do voip.sms.video.comcast.net, or
can you show how that would be represented?
Go back. Should I go back to the query? I think the query shows the, yeah. So, I mean, if you look at the query, I just put an attribute field into it, right, that has service associated with that. So just imagine that service, these are arrays, right? You just specify multiple services that are associated with the telephone number with the subject in question. So, I mean, you imagine an attribute field just like that gets in the record and is attached to the service URI. And that's something that's in Terry, but isn't in the example I was showing of the Terry record. And again, the alternative would be, though, if we literally were encoding these service identifiers into the domain names, that I think it gets syntactically, gnarly to show multiple services associated with the same resource. We can take this offline too. I can show you a piece of paper pretty simply.
Separate records, I think, but
okay, that's another possibility. Sure.
So actually, I'm a little confused here. Like, you have service here, but in the record, service is associated with the URI.
Well, this is a query. There's no record here. Yeah.
Yeah.
So queries have their own structure.
I understand that, but are you implying that? So what does the mapping from service of SMS to the record?
It's a discriminator of records that you want to be retrieved. So in other words, this you're putting a limit, saying I'm not interested in records that don't have this quality. So if you have a VoIP record, I don't even want to see it because the attribute I'm looking for in this query is just the SMS.
Henning, I think what we were somewhat dancing around, and this goes back to your relational model question that I asked earlier, and in terms of response, also in terms of the uniqueness of records. I mean, what are, in database terminology, what are primary keys and what are not, which are keys, and what queries do you support? Namely, do you support exact match queries only, or do you support Boolean type of queries, predicates type of queries, or do you support wildcard queries? I mean, all of these are fundamentally what we would like to do, and I think part of the reason that we've had trouble with enum is not just that sticking information in DNS is kludgy at best, if it's not intended for particular for that, and that the query model is by nature very limited. It's just very difficult outside a single domain to do enumerations and other things that you might like to do. So I wonder if we shouldn't think of this a little differently, namely that we actually have a primary key being 3 things, not 2, namely the global identifier, telephone number in our case, a service ID, SMS in your example, and a third randomly assigned thing that I normally don't query for, but allows me to have multiple entities. So for example, again, think of the video relay service example. I could have a telephone number which tells me that the provider for that is a carrier. that gets the trunk to the video relay service provider, and I have a second entry which tells me that the video relay service provider that provides the upper layer service, or application layer service, if you want, is whoever that company A, not related to that. And similarly, I can think of attaching the kind of better business record, whatever else I have, with that for the same service. Namely, they have certified, they only attest to the fact that this is my voice number, actually, kind of an EV version of a certificate in that, and I have that. And secondly, so I don't think that's hard to do technically. It fits very well into your model. The harder question, which changes what, particularly in the federated model, what you really want to do is how you get into the wildcarding piece, or actual queries that are not simple, give me either all subject related records by removing the attribute field, but is clearly just simply a AND query of exact matches, which is what you have here currently implied. And I think this is true for both proposals, if I understood correctly. So I think the discussion needs to be had early on, because it affects what DHTs don't work very well, for example, with SQL-like queries. I mean, it just doesn't compute, literally. But they work just fine with replication. It's not a big problem to have SQL semantics or LDAP semantics if you want to take something closer to home.
Yep. I'll let Alex talk about, we can talk about Luff and Nerf. So I was thinking about talking about Luff and
Alex
Nerf.
Mayover, I can share some of the horror stories of strings that you have been watching very closely, I hope anyways. What was a significant struggle was the difference between being able to query for a range, being able to query for a non-decadic range, if that's the correct word. You know what I mean? And all kind of weird collections like variable number lengths. So I think, depending on what you said, you need to figure or decide at some point whether it's just the exact number or whether it's essentially supporting several types of queries for several collections of public entities, public identities. So,
I think at least I've been looking at, like, I do want to have something like a search function.
Yeah.
I mean, I'd say that the way that we would instantiate that search function in a RESTful API, would look like, you would say, give me the data structure of all the things that meet the following search criteria. And so it would be almost SQL-like, right? You would be interrogating a service and it would perform some hamster wheel function in the back and, mint a response for you, which is a very different matter, I think, than interrogating for things that are likely to yield records. I think that would be yielding a collection of pointers to records rather than a record itself. And I think that's how I've seen the search function as being different from this specific query function. Now, that much said, I mean, we've only really sketched this, like I said. I mean, we're still trying to figure out if we've got the data model right, and this is, like, I think, the first real proof of it that we're exploring now. But I think it is possible to do search. You just need to look at search like something very different from the other functions. And I think getting to the limitations of the DNS, you just can't do that with something like the DNS. But you can with, like, a RESTful API, right? I mean, you can just say, like, give me the pointers for all the records are associated with this, and you'll get back a JSON structure that has them all in them.
I think that the important use case in that case is I think you still remember the weird European way to route numbers. So they are allocated in blocks to service providers, and if a number is ported out, it's actually being a hop-by-hop routing. So actually, the serious service providers route it directly, and the others route it to the block owner, and the block owner is obligated to forward it to the other one. So the question is whether that protocol would actually sort of do the hamster wheel thingy behind to, like, give an entity the direct destination, or it would, like, return both information, like, okay, the block's going there and the individual number there. So it's like zombies from the past.
Yeah, I know. Well, and I get it. I mean, I think this also goes back to our point about what's the job of the actual, like, SIP, as opposed to this lookup function, right? And unfortunately, there is going to be a lookup phase, and then eventually you're going to throw a call over the wall. And even if you think that you have the right route to it, it could still be forwarded, right? I mean, we're never going to be able to totally, like, mitigate that. But I think the truth of the matter is, I can imagine very delegative approaches to this, where you go to one service, inquire, and it says, actually, the record for this resides somewhere else, and you then go and acquire the record from them. the Terry model is intended to be completely agnostic to those kinds of architectural questions. And again, this is something you simply can't do with the hierarchy of the DNS, right? And that's like one of the reasons why this is a much more interesting model.
Yeah, it's just a question whether so what you're saying is that the model actually would allow for the hamster wheeling to happen both on the server side and both on the client side.
It would, yeah.
Okay.
I'm trying to figure out on that. So when these things are provisioned, they're going to be provisioned also in ranges sometimes, right?
Mhm.
And the signatures occur at provisioning time, not when the record's returned.
Correct.
So it's like if I ask for a range of things, I might get like a handful of objects that are like those ranges plus other stuff and their signatures and all of that. And then it's up to me as a client to kind of winnow that down to what I care about.
Yes.
Okay.
Now, they're your query intermediaries. I have them as an entity in this. They're actually allowed to perform weird functions that, for certain environments, would whittle it down for you. But
Right, but then they would need to like re-sign it with something that I
Yes.
would trust. Okay.
yes.
So, Henning speaking, and I do believe that given the DNS experience and other things where we've tried to do a little bit of wildcarding here, a little bit of, and then we made a little bit of regex there to take some of the enum examples, all of that. You get almost all the complexity, but you never get quite the generality that you really wanted.
Mm-hmm.
So I fully recognize that depending on the implementation structures, that some implementation will not be able to do the kind of queries that you would want to do, and that's perfectly fine.
Mm-hmm.
But if you build an instance of that which does not support, because of the choices you made, does not support generalized predicate queries, good. And that's just, hopefully you made that decision knowing what you got yourself or not.
Yep.
But I would advocate just is essentially what we're building is a version of either, if you like it, it's a NoSQL type database or a SQL type database, whichever way, but probably more likely a somewhat of a hybrid between the two, namely in the sense that it has the ability to add additional attributes to that without redesigning the whole database, without doing a schema transformation.
Yep.
Because there is no schema
There's no schema,
directly except for some fixed fields. Yet also allowing predicate style queries because we know how to do those in many practical implementations, and they're well understood in terms of correctness and operations. We don't have to invent those. We have some history of doing that in LDAP and actually in the service location protocol as well, which is not widely used for that anymore for a variety of reasons, but we know at least how to do those. And that also allows us to not have to glom on, where the alternative basically is you get one record or you get a million record and you go to, good luck sorting them out at the client side in that, which is basically the DNS model. You can do an AXFR if you're allowed to do that, and then you get to inspect the database. You get to do search local.
Yeah.
The one interesting question which I think we need to answer separately is the permission structure. Namely, one of the problems, as you know, from a telephone database is that not just for write access for obvious reason, but read access is fairly closely guarded as well for a variety of privacy and business reasons. Namely, I want to be able to charge for that, and I don't want people to make copies of the database and resell my data for a lower price. And
Terrible.
So both of those will likely persist. So I don't have a good answer to that, but I suspect there will be a different answer. Namely, I can see that I'm allowed to retrieve a record that is mine, and in some way, but I'm not allowed to query as a consumer, for example, for a record that is every prefix of 212 area code in it. And that needs to be part of a model assumptions. How can I express that, not just for modification, but also for read, so you don't rely exclusively on encryption and key materials, because that's not going to work. I don't think that maps very well
Probably not. And I think you're right. So yeah, I definitely think you're right. And I guess I've, been conveniently kind of hand waving that the services themselves will have some of that responsibility for the architectures that are relevant in the sense of the IPNNI, right, is a closed network. And the set of entities that have access to the IPNNI are prescribed. And, a service like this that existed in that environment would have that limitation to it. Whereas something like DRIP, say, if we imagine that was more open and that everyone was pushing and pulling numbers from it and experimenting and doing cool things, that would have a very different quality. You would want pretty much anybody to be able to query and get a route, right, for a service at the
It
end
could
of it.
support either model, right? Like
You
to be
could.
a
Well, that's my
node on
point,
the
yeah.
DRIP network, you require access credentials, et cetera.
Yeah. I think as well, the kinds of URIs, the kinds of services you expose, what ultimately the routing ID in yours ends up being, can either be very informative or it can be very opaque, depending on the preferences of the creator of the associated record. And a lot can be masked behind that. If that's just like an edge SBC for your network or something, you're not giving a lot of information that is going to be useful to someone on the other side of it. So I think there are some knobs to tweak around that, but I think you're definitely correct that the acquisition interface and the management interface need to have some permissioning system that expresses at least what the intention is of the authority that generated this for which query sources should be authorized. And there are some cases where that'll just be explicit or implicit in the design of the system, and then others where I think we'll need something like that. I'm not sure that's the lowest hanging fruit in terms of what the kinds of things I'm trying to get aligned at this point, but I agree we definitely need it.
Just to address some number block issues and things like that. I mean, I think in RESTful interface design, usually the nouns and verbs you pick are very explicit in terms of functionality. So I think we would have to have functions that are specific to number block related CRUD activities.
Yep.
But to address Henning's concern about that doesn't mean that the objects underneath can't be extensible JSON, that we can create new things and even have security association with each of them and things like that. But I think we shouldn't worry about adding new nouns and verbs for each function. I mean, that's typically what you want to do in terms of accessing a resource in a RESTful system.
Yeah.
Dave Crocker, the discussion has ranged in a way that leaves me confused about a kind of core point, and it relates to exactly the sorts of things that Henning was raising. There's this basic difference between any service, but especially a query service under a single administrative control versus multiple. So X500 was meant to be multiple. That didn't go so well. LDAP, besides simplifying the technology, does work well, but that's under single administrative control. Is the target here for a single administration? I'm not talking about how many users there are or organizations as users. I'm talking about administrative control of the query service.
Let me bring the graphic back up. I mean, I think the fundamental distinction here is between authorities and services. So there's a sense in which authorities generate the records and the relying parties rely. So,
right.
The service is merely an intermediary that gets those to you, right?
And one could actually do the DNS with I mean, you made the reference for this slide.
Yep.
And so I was taking this as highly conceptual and not implementation. If in fact you meant there's a single administrative entity in charge of the query service,
I don't.
The fact that there's different people feeding into it and different people pulling from it is not the interesting question. It's how many are administering the content in there.
Well, that's the authorities, though. So we imagine authorities could have relationships with multiple services. They could be.
So I apologize. I misspoke. I meant running the query service itself. Do you mean that as a single controlling entity for that service module?
Of course not. No, we've talked about it being distributed, federated, consolidated, or found on bus station or
And the operational examples that we have to base for doing that.
Well, for the bus station floor, not much. Again, we have a few proposals here for ways to do distributed hash tables, for example, to move objects like this. I mean, I could point you to other things that have this property that have been done with DHTs. I can certainly point you to centralized and federated alternatives for this. I think the way that this is practically done, say, in the IPNNI today, is basically federated, right? If you need to call Comcast, you go to Comcast service and you say, hey, like what, I've got this telephone number, what does it end up connecting to? That's a federated approach. And All we're doing here, again, is trying to get a bit of architectural commonality around these records injected into what I think is a set of familiar services of this form, though admittedly not the bus station form.
Okay. We've got about 10 minutes left, just FYI.
So just a quick comment on that is, I think it's useful to distinguish between two kinds of, even on the operation side, two kinds of models. And one is an untrusted model, which is more or less a federated X500 model, where there was really no notion that these entities have understood, if I would call the design correctly, although trust really didn't play as much a role during those early days, had any trust relationship with each other at all. And then the other one to answer a somewhat vaguely related example is the TV white spaces database in the United States, where there are about a dozen, so not hundreds, not thousands, because trust doesn't scale that well to that number, operate independent but consistent databases, and they can generally trust each other. Meaning if I put an entry in one, they will believe that they should also inherit that entry, that the other entity has validated whatever they need to do in that. So they are administratively independent. They don't share passwords with each other, but they are, by legal and other constructions, obligated to trust each other in that. And I suspect that in the telephone numbering space, we'll see some version of that as well. That in many cases, it will be a legal trust model, not a technical trust model, that will essentially say you get to be part of a club if you play by the rules, and we'll kick you out of a club if we are finding you to have deliberately violated those rules.
Just a comment on the operational side. I don't have good telecom examples, but in the cloud and container world, there's many services, including Google. There's open source examples actually, like etcd, Kubernetes, Console, some others that implement. In fact, Drip was pretty much essentially made to model this, where in the cloud world you're managing thousands, tens of thousands, hundreds of thousands of containers out there. They're going up and down. They need to communicate across multiple sites across the world. They have distributed registries essentially based on gossip protocols and things like that. So and that works extremely well. It's obviously running in very highly loaded systems. So I think that's one to particularly point to. I also wanted to maybe go back to, because I'm sort of still reconciling the service thing in my head.
Bring it back to the record example.
But so I think a big difference in what I'm putting forward and what you're putting forward, and maybe we need to intellectually come to terms with, is whether or not, and correct me if I'm wrong, a identity, like in your example here at sip:alice@example.com, should that try to, in the form that it is, should that represent multiple services as an identifier? Or in the model I'm putting forward is, I'm saying that is the identifier that is owned by either the provider or the user, depending how you want to look at it, and is how I reference myself to the world versus how I actually route calls and messages and other things. And I think it seems to me that's the fundamental difference of where we're at.
Well, and like I said, I think this is something that we always come up against when discussions get to this level, is how much we want to give these kind of directory services that sit in front of our real-time communication systems information about what the services are that are kind of behind the URIs that we're advertising. You could look at this as a multi-stage transformation, for example. I mean, imagine, you started with a telephone number, and you got this back, right? And like, okay, so I got sip:alice@example.com back from the retrieval operation. Now I need to figure out how to route that, right? Now we interrogate the DNS for these things ordinarily, though practically speaking, not as much as we probably should, according to RFC 3263 anyway. So I mean, you could imagine doing another Terry query to then get alice@example.com down to alice@voip.example.com. I mean, again, I could also imagine models where you get back this and you get back several of these services that represent different potential, VoIP versus video versus SMS, that you get multiple.
That I wouldn't disagree with. And you probably have your own local routing tables that might, just how we do things today in service provider world is, we map things to peering agreements and SBC destination, ingress, egress locations, etc. So we're not doing VoIP routing directly, but we have conversion tables underneath that do those things. That doesn't mean that we couldn't use this directly as a routing table if we want to get to the world where it is truly globally routable.
Well, and this too maybe gets us back to kind of why we're here, right? And I'm glad we have Henning here today, since Henning was one of the prime movers behind us starting to investigate. Kind of this isn't necessarily about what the service provider world looks like today. This has always been this speculative exercise, right? We're trying to explore what kinds of resources we think might be useful to have as number administration changes going forward. And so, I mean, I think we wanted to work with what we've got today, but I think we also wanted to be able to do, other things that.
Well, let me be clear. I'm not suggesting that we only support that model. I want something that can support both models.
And I think we can get that. Again, I think, I could encode URIs the way that you have them in your document in this, right? There's nothing prevents that from being voip.example.com and having a VoIP attribute associated with it, or however else want to express that syntactically. Again, I don't think that the semantic is actually different. So we were talking about this earlier, again, the reason why whenever we get to this point architecturally, like in our enum discussions, I always get a little cagey. It's because of things like how let's say that you have, so SIP is a rendezvous protocol that does capability negotiation. Once you send someone an invite that contains an offer, the offer is responded to by an answer. You use the offer and the answer to converge to the services that we share in common that we're going to communicate over. If you have something that's like a VoIP URI, does that mean that if we both share a video capability, we're not negotiating that? Or, again, because the thing is, SIP has this capability negotiation dimension to what it does. And yeah, we can kind of anticipate, this is a service that is available behind this, but does that mean this is the only service that this is? And these questions get very architecturally complicated. That's why I get cagey.
But couldn't it be that Comcast prefers to use voip.example.com and AT&T prefers to use example.com, and they can do their internal mapping? I don't like convention either, especially in specifications or anything. Sometimes you practically do those things for other reasons, but seems like there's some flexibility to really do what you want, but the model has to allow for that.
I think we're getting that.
Yeah, I want to give a minute to allow for logistical change over to the next working group.
Okay.
So,
I guess what I'd say is that I think we're close. I think if we go talk about this, we could maybe come back in the not too distant future with something that is more consolidated from what's in registry identity and what you see in this document, maybe fleshes out a bit more what the RESTful API might look like that supports this. And I hope that people would find this an exciting idea. If anyone thinks it's a terrible idea, please get up and tell us it's a terrible idea.
Or tell the list.
Or tell the list.
Yeah.
This is not about this, so just going back to our the problem statement framework document, could we set a deadline for when the reviews will come in from our reviewers?
That's a good idea. Is a couple of weeks good enough? Or
yeah.
Oh, that's true. That's true. Okay, a week after Thanksgiving then. Yeah, make it 3 weeks.
Yep. So that would be December 9. Thanks.
Okay, good idea. Thanks. Okay, well, let's adjourn from the room as quickly as possible because we have another working group that's starting up real time right away. So if we can have follow-on conversations be in the hallway instead of in here. Thanks, everybody, and see you next time.
saw the blue sheets in the sorry. Oh, okay.
So you have problems, I guess, huh? Ah. Did you do anything specific to fix it, or?
No, I mean, he brought in another box to convert it.
Yeah, okay. That's the other thing?